Find the solution set of the following linear inequations graphically. Let us begin. Now what we'll do, we will be considering the xy coordinate plane. So let us consider the first inequation, x plus 2y less than equals to 3. We're going to convert it to an equation. All we have to do is replace the inequality symbol with an equal symbol. So that means we now have x plus 2y equals to 3. That's a linear equation in two variable x and y. We're going to consider some values for x and y. So let's say when x equals to 0, then the corresponding y value, that's going to be equals to 3 over 2. And when we choose y to be equals to 0, then the corresponding x value will be equals to 3. Now the first one, x equals to 0 and y equals to 3 over 2, this is going to give us the coordinates of a point, which is going to be a solution of the linear equation. Similarly, the other one will be 3, 0, so that's going to be another point which satisfies the linear equation. The reason why we found out these 2 points, because we're going to plot these 2 points on the xy plane and join them with the help of a straight line, and that is going to give us the graph of x plus 2y equals to 3. Now as we can see here, the straight line x plus 2y equals to 3 divides the xy plane into two regions. One region is going to be above the line and the other region will be below the line. We need to check which particular region is going to be a solution to the inequality x plus 2y less than or equals to 3. For this, we are going to choose a point on the xy plane. Let's say we're going to choose the origin O. At the origin O, 0, 0, where our x value corresponds to 0 and the y value is 0 as well, the linear inequality is going to become 0 plus 2 times 0 less than or equals to 3. Now this gives us 0 less than 3. Now is this a true statement? Yes, that's definitely a true statement. 0 is less than 3. Now that only tells us that the region which contains the origin 0, 0 is going to satisfy the inequation x plus 2y less than equals to 3. In other words, we have to consider the region that is below the line x plus 2y equals to 3, because that region includes the origin. So this is going to be a solution to the given linear inequality x plus 2y less than equals to 3. Using the same approach, we're going to consider 3x plus 4y greater than or equals to 12. Let's use that. We have 3x plus 4y equals to 12. We're going to convert it to an equation. We're going to find 2 points and then we're going to sketch the line. As we can observe here, the line 3x plus 4y equals to 12 also divides the xy plane into two regions. One will be above the line and the other region will be lying below the line. Same way, we are going to consider the origin. So at the origin O, 0, 0, we'll check whether if it satisfies the inequality or not. So we have 3 times 0 plus 4 times 0, so that's simply 0. This is giving us 0 greater than or equals to 12. Now we know that's an incorrect statement. 0 cannot be greater than 12. Now this simply tells us that the region that contains the origin O is not going to be a part of the solution for 3x plus 4y greater than or equals to 12. In other words, we can only consider the region that's going to lie above the line 3x plus 4y equals to 12. Okay, now coming to the third inequality. So here we have y greater than or equals to 1. First what we'll do, we'll try to sketch y equals to 1. So y equals to 1 is going to correspond to a point 0, 1 on the y-axis, and we're going to consider a line that is going to pass through this point and parallel to the x-axis. Now we need to find out the solution region for y greater than or equals to 1. So that means if we choose the origin 0, 0, substitute this into our inequality. That means at the origin 0, 0. So if we use this particular inequality, we have 0 greater than or equals to 1. That's again an incorrect statement. That means the region that contains the origin is not going to be a part of the solution. We have to consider all values of x, or all the solution must lie in the region that lies above the line y equals to 1. And finally, we have x greater than equals to 0 and y greater than equals to 0. This simply tells us that we are in the first quadrant. So here we have the first quadrant. So we must be in the first quadrant. Now that we have sketched all the solution region for each of the individual inequalities. Our goal is to find out a region that is common to all of the solution. So here we cannot find any common region. For instance, we are in the first quadrant. We can see here there are 1, 2, 3, 4. So there are a total of 4 regions. So if we consider this particular region, let's call it region 1. Now this does not include, this is going to include the solution that's y is greater than or equals to 1. And it's not going to include the solution of x plus 2y less than equals to 3, because that lies below the line. And also it's not going to include the solution of the inequality 3x plus 4y greater than or equals to 12. So we cannot use this region. Coming to the next region, so this triangular region. So here we have only solutions belonging to x plus 2y less than equals to 3 and y greater than equals to 1. It does not include solution from any other region. So we have to reject this region as well. Similarly, we have to reject this region and all the remaining regions. So that means there isn't going to be any region such that if we pick up any point from that region, that's going to satisfy all the inequalities. So here for this particular problem, we will say that there is no common solution to the system of linear inequalities.